Okay, so we have 10 core properties of log. So the B is the subscript, the M and the N are on the same level as the log. Okay, so when it's multiplication, addition goes with multiplication. So we're going to do this both ways. We're going to go from an expanded logarithm, like this, to a single logarithm, and vice versa. So quotient property, B is the subscript, Mn is the fraction on the same level as the log. So when it's division, we have subtraction. Alright? And power property. So the B is the subscript, the M is on the same level as the log, and then the N just comes down in front of the log. So N log base B of M is how you would read that. And then change of base we're going to do for a Thursday for you guys, but just so you have it down already. Okay. C is going to be 10 in that formula. It's going to be log base 10 because then you can use your calculator. Remember the log button on your calculator is always log base 10. Okay. So we're going to simplify logarithms. We're going to rewrite it as a single log. So write that down. I already have the answers posted, 9 through 29 all. Your homework is odd, but sometimes if I post all, sometimes it'll help you solve some of those other problems as well, just to see it. Well done. Okay, so if I have a minus right here, which property do I use? Quotient property, right? Division, same difference. So this minus makes a quotient. So here's how you do it. You have log base 4 of 32 over 2. Yes, indeed. So that, I'm going to divide the 32 into 2. So I have log base 4 of 16. Now, as soon as I have a single log here and I don't have any variables, I can just set it equal to x and then rewrite it exponentially. Does anyone know what x equals? 2. Good. So 4 to the x, if you didn't get that, that's okay. 4 to the x equals 16, so 4 squared is 16. You want to see the rest of the math, it would look like this. As soon as the two bases are the same, you can set the exponents equal to one another. So x equals 2. So whoever writes these math books loves to do stuff like this. This whole nasty thing here turns into 2. That happens all the time. Just be happy that you end up with 2. Okay? Don't get mad because you end up with 2. Be happy. No stress. People get mad. They're like, really? But that's when it's different. You know why? It's the only even prime number. You think I was born to be a math teacher? It's the only even prime number. Think about it. Come on, think it. Okay, this plus, which property? Multiplied product property. This sits in front is what property? Power property. Okay, so here's what we're going to do. We're going to take this 6, and that is going to become an exponent on the x. We're going to take this 5, that's going to be an exponent on the y. So we're just going to rewrite that step first. So log base 2 of x to the 6 plus log base 2 of y to the 5th. And then we can write it together. So when we use that product property, we just write x to the 6th and y to the 5th right next to one another, because you can't combine them because the letters are different. Okay? So we get log base 2 of x to the 6th, y to the 5th. Done. So remember, the direction said rewrite as a single logarithm, so that's what we did. We're good. Okay, now we got double barrel example. Write those down. So it's example 1. Do you think I would write example 1 less than? In algebra 1, I'll just make up, they're like, what example are we on? And then I just make up anything. Like example 1 mollusk. This freshman, they find it fun. No offense to you, some straight. I see you as higher than that. Intellectual. Okay. So, what property do we use? Product property. So then we have to multiply. So when you use product property, just so you pay attention to this, you have to have the same base. If you have different bases, you can't use the product property. Okay? So we have to multiply 5x times 3x. What do you get? 15x squared. Make sure you multiply the x's as well. So this is a pretty easy one, right? 15x squared. I just multiplied 15x and 3x to get 15x squared. I said 15x, I meant 5x. 5x and 3x to get 15x squared. Okay, so now, this one, what is the 2? Which property? Our property. So we're going to take that 2 and make it an exponent on the 6. So we get log base 4 of 6 squared minus log base 4 of 9. And now what property should we use because of the minus? Quotient. What's 6 squared? 36. So we're going to write log base 4 of 36 over 9. What's that equal? 4. Log base 4 of 4, which equals? 1. So log base 4 of 4. Right? We could make this equals x. And then you could rewrite this exponentially. So 4 to the x power equals 4, what power is this? First power. So then x equals 1. So that's why log base 4 of 4 equals 1. So when it's the same base and the same number next to it, it always just equals 1. So log base 10 of 10, 1. Log base 100 of 100, 1. Log base x of x, 1. Yeah. Yeah. Right. So if you have an exponent up here and these two numbers are the same, the answer is whatever that exponent is. That's a good point. Yeah. Good deal. Alright. So that was the end of that. So E and F, you know it's a good day when we got example 1 E and F. Well, it's an elephant. Yeah. Banana? Holding a banana. With an F. Sorry. Okay, so we have, what 2 properties are we going to use on this first one? Quotient and power. I'll give you a chance if you maybe you get a chance to write it down. So all assignments were updated today, except what's been turned in this period to missing assignment, and I sent missing assignment reports on. So if you're one of the ones missing a bunch of assignments, get ready for a little talking to. So get them in by Friday, because I'm sending another one home on Friday. I'm getting kind of sick of missing assignments, just can't tell. Okay, so first thing we can do is take this 2 and make it an exponent on the 7. So that's going to become log base 3 of what? 49. So log base 3 of 7 squared, which is log base 3 of 49. So I started with this one because there's nothing to do with this one, so now I'm just going to bring it down, right it next to it. So then I do the quotient. So we have log base 3 of x over 49. Done. So when you have a number, as opposed to a number and an exponent over here, that's when you can usually simplify it more, but because we have this exponent here, you're done. Okay? Alright, so what property are we talking about on example 1F? Product property. So we're going to have log base 8 of 48 times 4/3. Remember, this is going to be, this section is going to be on the no calculator portion of the test. So if you can handle multiplying 48 times 4/3, that's going to be a problem for you. But here's how you do it. 3 divides into 48, how many times? 16. 16. So 3 divides into 48, 16 times. 16 times 4 is? Nope. 64. So log base 8 of 64. So when I have numbers as the base and the number next to it, I'm going to make it equal to x. So what's the answer? 2. Just to show you that step, 8 to the x power equals 64. And then I can write 8 to the x equals 8 squared. So x equals 2. So again, that whole big thing at the beginning equals 2. Find that gratifying, not frustrating. To make your life easier. So we're just kind of doing the nuts and bolts of logarithms. We're going to talk about how logarithms are used, some block dates, so you know. So we got to get these nuts and bolts. So now we're going the opposite way. We're going to expand logarithms. Okay, as opposed to writing as a single log, now we're pulling them apart. So in the numerator of that fraction, we have what mathematical operation? Right here, multiplication, right? So that means we're going to separate log of 4 plus log of x. And then we have division. So when we have division, subtraction goes with division. Okay, so here's what the final answer looks like. What is this? Log base what? 10. 10. Good. So log base log 4 plus log x minus log y. Done. That'll be like a really easy one. So you have to follow order of operations. So if we were to write this as a single log, I want to do this part first, and then I'm going to divide it by the y, right? That's why this makes sense. Because you have to follow, just like any other math, you always follow order of operations. Okay, so 2D. We only have C and D left, so you get time to work on your homework, okay? My secondary, this lesson took until like 4 minutes before class was up.
Because we're real smart.
The whole variety of reasons, right? There's genies in that class, like some knuckleheads in there for sure. Lots of some kids that ask like 8 billion questions. You guys are usually pretty good at asking questions. Some people ask too many questions, really. You sure get less? You get 3 questions, you know? And where you give you practice after? Like the question and practice?
Yeah.
No? Yeah, it's perfect. Okay. So we're going to have in this problem, what properties are we going to use? Quotient. And what else? Power. Right? Because we have an exponent, so we're going to use the power as well. So we're going to have, we'll just rewrite this beginning part, so log base 9 of x to the 4th power minus log base 9 of 729. So even on the no calculator part, I would give you a number like 729, because 9 times 9 is 81, times 9 is 729. So 9 to the 3rd is 729. I have faith in your ability to figure that out. Okay, you're going to have to like write it out to the side baby, but you can figure it out. So we're going to use the power property on this first one. So that 4 comes down in front of the log base 9 of x. So we have 4 log base 9 of x, and then minus, yes, it's going to be 3. I'm going to show a couple more steps though. 9 of 9 to the 3rd power. So log base 9 of 9 is 1. And then because of the power property, that 3 comes down in front of the log. So we get 4 log base 9 of x minus 3. Okay. So log 9, you get, well, if somebody else didn't get it, here's why. Rewrite it exponential, 9 to the x equals 9 to the 1st, so x equals 1. So this is technically 3 times 1, or just 3. So how are we doing? You okay? It's like a bunch of days where it's cloudy out, and people in Colorado, like, their emotions that go into nothing. It's weird. Okay. C and D, last 2. C, you're going to just love. So when you deal with a number like 250 and you're writing it, expanding the logarithm, you want to expand it until you have prime numbers. That'd be a good thing to write down, actually, now that I think about it. What's the prime number?
37.
2 is, 3 is, 37 is.
5.
Numbers that you can only multiply 1 in the number itself, right? 13 prime number. There are no other factors of 13. You can only multiply 1 and 13 to get 13. Okay, that's what makes it prime. So we want to expand until you have prime numbers. So we're going to rewrite this. We're going to go log of 3. I'm just going to deal with this one first, but I'm going to rewrite this other one as well. Log base 3 of 37. So this is the prime number, 37, prime number. So we're done with that piece. But this one, 250, we have to divide it out. So what's the prime factor of 250? 5. Okay, what's the smaller prime number of 250? Smallest is 2. Okay, so we're going to divide it out. Log base 3 of 2 plus, right, because this number's going to multiply to get 250, plus log base 3 of what? 3 of 125. So 125 is what number to what power? 5 to the 3rd. Okay? So we've got log base log base 3 of 2 plus log base 3 of 5 to the 3rd power. So we're going to take that 3 and write it down in front. And we still have this up here, right? Log base. So minus log base 3 of 37. So we have log base 3 of 2 plus 5, or no, 3. Times log base 3 of 5 minus log base 3 of 37. Okay, so 2, 5, and 37 are all prime numbers, so that's how you know you're done, when you get to all prime numbers. They can't do anything else. None of the bases, like it's not 3 of 3 here, it's not 3 of 3, right, so you can't do anything else, you're done. That's the answer. Yeah, great, isn't it? Okay, so we're going to grab this one from up here, log base 3 of 9 x to the 5th. So that one poses some issues as well. So just going left to right, what operation is right here? Multiplication, so in between, we need a what? Plus. So we have log base 3 of 9 plus log base 3 of x to the 5th power. So that 5, the exponent right here, it only applies to the x, not to the 9 as well, right? How could we make it apply to the 9 also? Parentheses, right? Because there are no parentheses, the 5 only applies to the x. Okay? So now we can use the power property here to write that 5 in front. What's log base 3 of 9 equal? 2. Who said 2? Nice. Okay, I'll show you why it equals 2 for those of you that didn't get that. So I'm going to rewrite the second part first. So log base 3, 5 log base 3 of x. So we're done there, can't do anything else. And I'm going to show you over on the side why log base 3 of 9 equals 2. So we can set it equal to x. Rewrite this exponentially. 3 to the x equals 9. So hopefully you know 3 squared equals 9. You could also write like this. Right? So then when you have the same basis, you can make x equal 2. So this is just 2. And then you're done. Okay? You have to do that, right? In your class. Otherwise you lose points, right?